The main reason that we sort our data is to keep our data in a well-organized manner. By doing so, searching an element is quite easy. So, the main purpose of sorting the data is to simplify searching. There are many sorting algorithms. Selection sort is one of the basic sorting techniques, and its approach is quite straightforward. Let's start. Let me imagine an array of 5 elements. You can see all the elements are completely unordered. They are unsorted elements. These elements are before sorting. After applying selection sort, we can either arrange elements in ascending order or in descending order. As of this example is considered, I am arranging elements in ascending order. Then the output should look like this one. Now let's see step by step how this can be done using selection sort approach. This is an array of 5 elements. According to selection sort, what we do is that we'll pick a position. Always the position starts at 0. Whatever the data element that is there at position 0 is compared with all next elements one by one. And whenever we compare, if they are not in ascending order, we'll swap the values. For an example, the first position is 0. The value at 0 is 25. 25 is compared with the next element 6. These two elements are not in ascending order. Swapping takes place. 6 comes here, 25 comes here. And then we'll stick with the position. 6 is compared with 21. Swapping is not required. 6 is compared with 9, swapping is not required. 6 is compared with 24, swapping is not required. But in case if swapping is required, swapping would have taken place. Now I can say the work that is related to position 0 is completed. That means first iteration is completed. We'll proceed with the next iteration by making our position as 1. When position is 1, we'll do the same job. The element at position 1 is compared with this one, this one, this one, and if swapping requires, swapping takes place. And afterwards, you can see that second iteration is completed. And I'll select the position as 2, and then I'll proceed with the same job. And then position is 3, the same job. And there the job ends. And finally, you can see that array is arranged in ascending order. The main hint point for the selection sort is position, because the entire process depends upon the position element. Let's do it. Initially position is 0, next is 1. 25 is compared with 6. They are not in ascending order. Swapping takes place. After swapping, 6 is kept at position 0 and 1 is kept in the next position. We'll proceed with the same process. Position is still 0, next is incremented to 2. Now 6 is compared with 21. They're already in ascending order, no swapping is required. Increment the next position. Next is 3, but position is already 0. 6 is compared with 9, no swapping is required. Next is incremented to 4. 6 is compared with 24, no swapping is required. According to the values that I have taken, fortunately swapping did not take place, but in case of other examples, if swapping demands, then swapping will definitely take place. The first iteration with respect to position 0 is completed. According to selection sort, if we are arranging elements in ascending order, then we can see that minimum element of all those elements will be kept at position 0 after first iteration. It means that after second iteration, the second minimum element will be occupied in the position 1. The third minimum element will be occupying in the position 2 after third iteration. So this is the technique of selection sort. Let's do it now. Position is incremented to 1. Next element is 2. So 25 is compared with 21. They are not in ascending order. Swapping takes place. After swapping, the position will be 1. Next is incremented to 3. 21 will be compared with 9. They are not in ascending order, swapping takes place. And then next is incremented to 4. 9 is compared with 24. They are already in ascending order, swapping will not take place. Here the second iteration is completed. You can see that the second minimum element is automatically kept in the position 1. We'll repeat the same thing for rest of the elements. Position is incremented to 2 and next element is 3. 25 is compared with 21. They are not in ascending order, swapping takes place. Position is 2 and next is incremented to 4. 21 is compared with 24, swapping is not required. Third iteration is completed. After third iteration, you can see that the third biggest element of these unsorted elements is kept in the position 2. All green elements are already sorted elements. Now we'll proceed with the remaining black elements 25 and 24. The position is 3 and next is 4. 25 is compared with 24. Swapping requires here. Swapping takes place. And after this iteration, the process terminates. Because the last position that we can work it out whenever we are having 5 elements in the array is 3. It means that whenever we are working with n number of elements, the position is always less than n minus 1, where n is number of elements in the array. What is the logic to write the program? We require 2 loops which are nested. Parent loop for position. For every time we pick a position, there should be a chain loop to iterate for the next elements. Every time we iterate in the chain loop, we need to compare between the position element and the next element. Wherever the swapping is required, swapping will be done. We'll repeat this process till end. And at the end, we can see our array is in ascending order or in descending order. This is the main logic. This is the parent loop, which runs for every position starting from 0 to n-1. For each position, this is the inner loop that is written to pick a next element, which always starts from position plus 1. The next should be always less than n, and each time next is incremented by 1. Whenever the condition is true, we are comparing a of position with a of next, and in case if a of position is greater than a of next, then we'll swap a of position and a of next. Let's run this algorithm step by step. Initially, position is 0 and next is 1. When position is 0, condition is true, you get inside. Next is initialized to 1. Since already position is 0, next will become 1. 1 is less than 5, condition is true, get inside. Now you are comparing with a of 0 with a of next, that means 1. A of 0 and a of 1, that means 25 is compared with 6. Since 25 is greater than 6, condition is true, you'll get inside, and we are going to swap these two positions. After swapping, we'll get back to the inner loop. You already know that as long as your inner loop condition is true, we cannot come outside of this inner loop. Once after coming out of this inner loop, we'll get back to the position again to increment the position. So now the next position is incremented by 1, the next will become 2. Already position is 0, now next is 2, so 6 is compared with 21. Swapping is not required, this condition will fail, so swapping is not required. Next is again incremented to 3, condition is still true in the inner loop, 6 is compared with 9. And then next is incremented to 4, a of 0, that means 6 is compared with 24, swapping is not required. And then the next position will become 5, 5 is not less than 5, condition fails, and you'll get back to position, and here is the place where position value will now change to 1. Now position is 1. I hope you got the point. Next is now 2, 25 is compared with 21. That means a of 1 value is compared with a of 2. A of 1 is compared with a of 2. Since the condition is true, you'll get inside and swapping takes place. And this goes on. The next is again incremented to 3, 21 is compared with 9. Next is again incremented, 21 is compared with 9. Swapping takes place. And then next is incremented to 4. 9 is compared with 24. Swapping is not required. Second iteration is completed. Afterwards, next value will be incremented to 5. 5 is not less than 5. You will get back to position again. Now the position becomes 2. When position is 2, your next is freshly initialized to 3. 2 plus 1 is 3. So 25 is compared with 21. Swapping takes place. Next is incremented to 4. That means 21 is compared with 24. Swapping is not required. Third iteration is completed. And again, the position value becomes 3. And since the position value is 3, next is nothing but 3 plus 1, 4. So 25 is compared with 24. Swapping takes place. Afterwards, the next value is incremented to 5. 5 is not less than 5. Condition fails. And then you will get back to position. Position value becomes 4. 4 is not less than 4. n minus 1 is 4. When n is 5, n minus 1 is 4. 4 is not less than 4. You will come out of the position also. So it is the ending point to stop the iteration. Thereafterwards, you can see it means that our approach is stopped because it had ended up doing the entire process. After doing the entire process, you can see your array as ascending order. Now let's see the full program and execute it. This is the entire program. The main logic of the program is already explained, and here roughly I'll talk about the program steps. I've taken an array of 10 elements. POS is a variable for position. Next is to maintain the next element. N to store the number of elements. Temporary variable is used for swapping, and I for a simple iteration purpose. I'll ask the user to enter the n value because I have taken an array of 10 elements. And the user's interest can be anything. That interest I'll store in n. The values that are entered by the user will be stored in an array using this simple for loop. And then I'm just printing the values that are entered by the user. Just to tell the user that these are the values before sorting. I'm just showing. This is the main logic that I have explained you just now. This is the parent loop for position which starts at 0 to runs up to n-1th position. And this is to change the next element which starts at position +1 to run up to n number of times. And each time we get inside in the child loop, we are making a comparison. Accordingly, we are swapping. And after this approach is completed, finally I am displaying the values after sorting. The same array elements I am displaying so that we can see the sorted elements as an output. Let's compile this program. Since there are no compile time errors, I am executing the program. I am providing the total number of values to be 5. I'll enter some random values which are absolutely unsorted elements. I've taken 5 input values which are completely unsorted. Thereafterwards, I'm just displaying according to the program values before sorting. These are the elements. Values, and here is a place where soon after the values are displayed, our 2 for loops have executed, and finally this is the output. And finally, this is the result that we got. You can see that the array elements are arranged in ascending order. What is the timing complexity of this approach? To calculate timing complexity, single steps like assignment or declaration steps are not counted. For each position, we are running an inner loop. Let me count how many number of times the position will change. The position will change from 0 to n-1. So at a worst case, the position loop will run n number of times. For each position, let me count the total number of times the next position is changing. The next will start from position 1 and it goes up to n. When position is 0, it means that next is also traveling n number of times. It is iterating n number of times. So the total timing complexity is order of n square. N into n. For each value of position, you are iterating n times. So if position is running n number of times, the total timing complexity is n into n square. There are 2 important cases in terms of timing complexity. One is best case and the other is worst case. Here I talked about worst case timing complexity. The best case timing complexity for selection sort is also n square. Now coming to the point, what is best case? When we are trying to sort out the data which is already sorted, if the given input is already sorted, then what is the timing complexity our selection sort is going to take? Even for the sorted data, selection sort is going to take the same amount of time, order of n square. For both the best case and worst case, the timing complexity is order of n square. Because selection sort is not an intelligent algorithm with respect to best case timing complexity. It is innocent that it doesn't know the data values are already in ascending order or in descending order. Without knowing that fact, it applies the entire approach. And of course, swapping will not take place, but the comparisons will take place. 2 loops will run a total of n square number of times. For that reason, for all the cases, you need to remember the selection sort's timing complexity is order of n square. One of the biggest advantage of selection sort is that when it is compared to any other sorting techniques in this world, it takes very fewer number of swaps. That's all. We are done.